Section 5.5, Day 2, Complex Numbers and Roots. Please write down the essential question. How do I solve quadratic equations with complex roots? The first part is kind of a review of the Day 1 video, or the 5.5a video. A complex number is a number that can be written in the form a plus bi. A and b are real numbers, and I is equal to the square root of -1. Every complex number has a real part A and an imaginary part B. We also talked about that. Down below, you need to pause the video. This is important information to write down. A and B are real numbers, but A is the real part of the complex number. When B is multiplied by I, then B is the imaginary part of the complex number. Pause the video and write that down. Example 1, find the zeros of the function. All right, so they're asking for the zeros. We can also call them the roots, but I can't really call them the x-intercepts because I know that I'm going to be dealing with zeros that are not x-intercepts. They're imaginary numbers. If this would have crossed the x-axis, well, then I could call them x-intercepts, but it's not going to. Number 1, I'm going to set the function equal to 0. We already know how to do that. I can try to factor that, but that's not going to work. I can't find two numbers to multiply to 13 and that add to 4. So therefore, I'm going to use complete the square. And remember, when we complete the square, A must equal 1. And it does. So now I'm going to get my constants on one side and my variable terms on the other. And we're adding b over 2 squared to both sides. B is 4. 4 divided by 2 is 2. 2 squared is 4. Negative 13 plus 4 is negative 9. And now we already know that this will factor into x plus 2, which is x plus 2 squared. Take a square root of both sides, and the x plus 2 comes out because that cancels, which generates an immediate plus or minus. This negative underneath, remember, refers to I, because it's the square root of -1 times the square root of 9. So it's going to be plus or minus I times 3. And I'm going to write that right now. I'm going to erase this and write it in the form plus or minus 3I. Well, I'm trying to solve for x, so I also have to do one more step. I have to minus the 2. And after I minus the 2, I get x is equal to -2 plus or minus 3I. I always write what I add or subtract first, and then the plus or minus 3I. Now you may say, well, wait a minute, I don't see two answers. Yes, there are two answers. X is equal to -2 minus 3I, and x is equal to -2 plus 3I. That's another way of writing it. Example 2, we're going to do in class. Example 3, find the zeros of the function. Set the function equal to 0. First, I always try to factor. Two numbers that multiply to 5 are 5 and 1. They'll never add to -2, so we know we have to complete the square. I can't use the square root method like I did in video 5.5a because we need b to equal 0 in order to do that, and b doesn't equal 0. So I'm going to subtract 5 And I already know A is 1. So now I can get ready and add the B over 2 squared, which is just 1. And now I can factor then into x minus 1, x minus 1. Two numbers that multiply to 1 and add to -2. And now I can take a square root of both sides. That cancels. So I know over here it's going to be plus or minus. This negative underneath, remember, represents I, and the square root of 4 is 2. So 2I. And that's just going to be x minus 1. Add 1 to both sides. And our answer is going to be x is equal to 1 plus or minus 2. Hold on here. Sometimes that happens, and we're going to get back and fix that. There we go. Plus or minus 2I. Again, that is 2 answers. 2 zeros. You do not have to write what's in blue. Writing what's in red is just fine. 1 plus or minus 2I. We can't add these together because the 2 has an I attached. It's a complex number. We have the real part. We have the imaginary part. We just found the zeros. The solutions -5 plus I root 10 and -5 minus I root 10 are related. These solutions are a complex conjugate pair. Okay. Notice negative in front, negative in front. The only difference is this is a plus and this is a minus, just like all of these answers. The plus or minus, that's what's different between these two answers. That's what's generating 2 roots. Their real parts are equal, -5, and their imaginary parts are opposite. I root 10, negative I root 10. Or imaginary part, I should say, is root 10, negative root 10. The complex conjugate, this is an important term, of any complex number is a plus, of any complex number a plus bi is a minus bi. The only thing that changes is the imaginary part. The sign changes, either from positive to negative or negative to positive. If a quadratic equation with real coefficients has non-real roots, which are these, those roots are complex conjugates. That's exactly what's happening here. Just like up here, 1 minus 2i, 1 plus 2i. The real part did not change, only the imaginary part. That's what this is saying. Helpful hint, when given one complex root, you can always find the other by finding its conjugate. Example 4. Find each complex conjugate. First, make sure they are all in the form a plus bi. Because remember that what's changing is the imaginary part. So 9 minus I is going to be 9 plus I. This is not in the right order. We have to change it first. A plus bi. We have to put it in this form. So then the complex conjugate is square root of 3 minus I. If you would have just changed that sign to a minus, you would have got it wrong. It needs to be in this form first, and then you change the sign in front of the imaginary part. Oh, this one's kind of different. Well, if we need it in the form a plus bi, there is no a. So it's really 0 minus 8i. So it's just 0 plus 8i, which means it's just 8i. All we had to do was change the sign in front of the imaginary part to a positive, but I'm just showing you how I got there. Video questions. Please do these in your notes.